Well, hi, and thanks for joining me here this morning. Beautiful sunny day here. Makes me think spring is really going to get here at some point. It's fantastic. So here's where I'm at with this radio now. I think I've overcome or stumbled my way through every important problem in this radio. I believe they've all been removed. So what's left to do now is to ensure that this radio's performance is peaked up where it should be. Last time I played this radio, I put a nice big loop antenna on it and compared it to a modern little transistor radio, and it stood up really well. I was really impressed. And even at that point, I had not followed the alignment procedure as specified in the manual. I had just fiddled around with all these alignment adjustments here, 1, 2, 3, 4, 5, 6 of them. But you know, having gained an awful lot of time on this, I've been driving this guy around for quite a while now. I was able to more or less tune this by ear successfully and get the thing working. But I don't know that it's performing where it should, and I don't even know how well a radio like this should perform. I'm not even sure how would I even measure it or check it and all this kind of stuff. So you know, there's an audio portion to this radio, the last tube and the two tubes over here, which I'll put back in. I have done some testing along the way, and it certainly leaves me with the impression that the audio amplifier stages are really great. Look, can you see that there's a small defect right in the glass here? In this. And that gives you an idea how old these are, because you would never find a modern tube with a defect like that in the glass. Now, how old are these, Jim? Well, these are probably right from the same vintage as this radio, right around late 1920s, so 1928, 29. These could well be replacements from the original ones, or they could be the original. Could still be the original. Don't have any replacements for these to swap them out or anything like that. They're a little bit rare. These are 71As. They're just a little bit rare. Okay. So the bottom line of that is I don't think there's much audio checking I need to do. I'm not going to concentrate on that part unless something shows up that says I should. I really want to concentrate on the RF part of this radio and how well that is working. And how will I do that? This radio is really like 3 or 4 radios in a row. Each one's output becoming the input of the next, which is kind of how you would imagine most radios work. But of course, modern radios are frequency shifter radios. They convert the received frequency at the antenna to an internal frequency. They work on a whole different principle from this guy. This guy is real simple. It's like 1, 2, 3, maybe 4 radios. Let's see, 3 RF tubes. So let's say 3 boosting radios in a row, each one jacking up the same signal and then presenting it to the detector tube here. So very, very simple. You can even tell this by looking at it, because you see the same thing over and over through the radio. These are the same dimension. Everything's the same. So you can almost imagine they're simply and also these coils that are under the copper. Ooh, I can't lift this up anymore. Under those copper domes, identical. Everything identical. So they could have put 3 more on the front of this if they wanted to. The effect of that would be to sharpen the receiver's selectivity, so you're more focused on the signal you're interested in and you're rejecting all the others. Kind of get the shape there. There comes a point where doing that will cause the bandwidth to get so sharp that you will only hear a muffled response in the speaker. So I mean, there are limits to this, and besides, if you got 6 of these in a row, good luck getting them all lined up and tuned properly. It's hard enough with this arrangement. So now I have a bunch of tubes I can pick from, and I think I have 2 detector tubes which seem to test and work pretty much exactly the same. Sometimes, often, the functioning of the tube is less related to the characteristics of the individual tube and more to the circuits around it. Now I had tested these and I'd given a qualified rating on a lot of them, just putting in the word OK if it was working, and then minus or plus depending upon if it was a little worse or a little better than the rest. So this is a -1, this has got 2 minuses. I'm sure I'm on my way to testing all these again. This is a -1. That's got 2 minuses. So one of the things I'd be interested in, these are all the same kind of tube here, number 26. I'd be interested in where should you put the stronger tube. I've been thinking about that. I can't think out any logical way to come up with that. Do you want the strongest tube at the start? Or do you want the strongest tube at the end? Or does it even really matter? Matter enough to matter. Does it matter enough to matter? 26, so this one's... Let's see, have I got another one? I do, but I don't have the... okay, we'll put this one in because we know for sure it's working. So, now the owner of this radio, Mr. M, did pick up some more tubes. Ended up with some more of these and another detector tube. Now I really want to start with the original detector tube. See, it has 5 pins on it. These ones only have 4. Where's my other? Where'd the other one go? Okay, so the other one has wandered away for the moment. So we'll start with this one. I believe I have 3 of these and one of them is a dud. I think that's the situation if I remember right. I've been working on this radio for so long now. Okay, so we need another one of these. Here we go. You can see the difference in the bulb shape here. You know, this style bulb, it's probably easy to make the glass dome. It's probably the situation here. But all the elements inside are just sitting in there, free, and when you whack the tube, free to move around. Now this shape, where they neck in the top of the globe, provides a place that they can put a structure. Here they've used mica to reach out and touch the inside edges of the glass and provide rigidity to the components inside the tube. So again, if you're shaking it, it's got some support at the top here. That's why tubes are shaped this way, and older tubes are not. You know, you'd think, wow, somebody would come up with that idea immediately, wouldn't they? Well, you know, it takes a human being to get their head in a space to think up these kinds of ideas. And as much as they look so simple when you see it after it's been thought up by somebody else, it can take a lot to come up with. That's what I found anyway. Good ideas take a long time to show up. Sometimes the most obvious things are the least obvious. Okay, so we got almost all the tubes in. I still got to put one. What did I do with it? What am I up to here? Talking and not thinking. Okay, so we got all the tubes in. First thing I want to do is make sure this radio still works after me monkeying around with it. Now, I did discover putting on a long wire antenna is a very, very poor way of feeding a signal into this radio. It really benefits from a tuned antenna at the front. So, but for the sake of my testing here, I really want to feed in very much a controlled signal. So I think I'm going to want to use my signal generator. Let's flip it on here and get it warming up. I see my assistant is coming to help me here. Come on. Come on. Don't be sniffing everything along the way. And there we are. Shadow has come to help out with this. So I'm going to need the speaker on here too. Right. Now, I've been exchanging a couple emails with someone who's just starting out in a radio repair game, and they got a radio very much like this, maybe even a couple years older that they're starting out with. And I was sharing my experience with this one. Basically, sharing pain. And yeah, I think this is a great radio to mess around with. Very different from the modern ones, but as simple as it might be, it still has definitely its challenges. Put these away here. I mean, this one drove me nuts because there was a shorted wire in it, which I found early on, and then later I kind of forgot. I found the shorted wire, cleared it, and then later I guess the short reestablished itself, and I just couldn't get my head around that. Carried on doing a lot of work with a bad short in here, but the thing is, I did want to spend a lot of time running around this radio back and forth, up and down, left and right, trying to discover everything I can about it. I don't do this style of radio too often. This is maybe the third or fourth one, and I really struggle with them all. Really struggle. Except for one. There's one radio, and I won't go into all the details, but it wasn't here in my shop, but someone had a radio of this vintage, and we literally plugged it in the wall, turned it on, and the whole thing worked beautifully. And there was nothing done to it. As far as I know, it was absolutely original from the 20s. So, and hearing that radio work is what let me know that these ones can all work. These can all work. And that has driven me nuts trying to make this one work. Okay, wow, I'm just talking up a storm here. Before I came in, I thought, oh, what am I going to say? By now I should realize there's never a shortage of what I'm going to say. Now, originally when the radio came to me, there was an antenna wire, which I've replaced. It went straight, essentially, through this tuning coil here, straight to the grid of this tube. And with this capacitor involved here. On the schematic, it shows you need it shows a small capacitor, I think I can't remember now, 0001 or something like that. Very small capacitor in line with this, which wasn't in line with it. I've installed that capacitor. It's down under here now. So what I'm thinking is, what I want to avoid is jamming a powerful signal, too powerful of a signal coming out of here into the radio, without realizing that some of the bad effects of the radio are due to too much signal in the front end. This is a common problem with testing radios. Let me get a cord for that. Okay. Often when you start out working on a radio, it's very weak. And if you've got this kind of equipment, you tend to put a strong signal into it to hear something come out the other end. Let me just check something about this before I go any further. One of these two boxes has a... Well, you know what? There's a capacitor at the end of this wire now. I don't have to worry. I don't have to worry so much. Come on. Really helping out here, kitty. Maybe I should plug this in and give you a real treat. Yeah, chow down on that. Thank you for that. Okay, so having said that, I will still put in this. I'll put in this simulator. This will present the signal generator with the sense that it's feeding into 50 ohms, which is what it likes. The radio itself is very high impedance antenna input. Okay, so we're going to leave this just like that for now until we get the radio operating. Take this one step at a time. Now, one of the things I've been thinking about is how can I look at the signal as it travels its way through the radio, and there's lots of easy opportunity up here. Each one of these pieces is connected directly to the grid of the tube here. So you can see there's a rivet, 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 rivet. There's 4 pins. What are you doing? Good for you. There's four pins, and there's rivets for each one. So grid, 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 and the grid. Very easy to... what are you doing? Fun, eh? Yeah, this is fun. Don't be pulling it off. Come on. These are really important pieces of paper. I do not want you eating it. Where to go? Yeah. Yeah, nothing like a piece of tape for cats to play with because it sticks on their paws. It drives them crazy. But leave my tape there. Okay? How helpful you are. Fantastic. Okay, now another thing is the frequency we're going to have the signal generator going at. I'm going to put it up a little higher. At, around 800 or so. A little more in the middle. How about 900? How about 800? 800. A little more in the middle of the AM band. So I was talking about monitoring the signal and picking it off at the grid here, which is a good idea, except if you touch the grid with almost any instrument, you'll throw this radio off instantly. So I think that's another thing about this radio is it's a little like being balanced on a knife edge when it's all tuned up. It wouldn't take much to make it come right off. Come right off the knife edge. Speakers in, power supplies, plugs up, antenna ready, cat chewing. I think we're ready to go here. Okay, so we're going to plug it in my little power box. Now, because I've done quite a bit of work to the radio since the last time it was switched on, we will certainly keep our eyes open on these 2 lights here. You ready, Cat? Are you in position? Okay, she's in position. Here we go. Okay, a little hum. All sounding normal. This radio takes a long time to warm up. You know what? Now I think I'm just a little nervous with you up here. So since I fooled with the transformer in here, I'm a little worried about that. Not too worried since everything's working. Gee, I saw I think I had three thumbs down on the video where I worked on this transformer. Well, I'm telling you, it's way thumbs up in my book. You know what, Cat? This is just getting a little too tight for you here. Okay, with everything operating, why don't you just say goodbye? This cat doesn't really like being held. It's not a lap cat. Okay, is it warmed up? Now there's nothing on the antenna here. Okay, we're operating with quite a bit less than, we're operating with around 100 volts supplied to the radio. A little under 100, maybe 90. Sounds like a radio. Let's tune them. Seems sensitive up here in this frequency range. This is the top of the AM band. Seems to lose sensitivity down here. But it seems to be working okay. So what we'll do, like okay considering it's not properly aligned. There was stuff coming out of the speaker. It appears to have something to do with the antenna. So again, I think the lack of sensitivity is really more indicative of no antenna. So hey, why not, let's just throw an antenna on it. I know this is not supposed to, even though my experience has been lousy with just a piece of wire antenna. That's what we'll do, just for fun. Yeah, this is all about fun, you know. Okay, here we are. Let's clip it on here. It's nothing more than a piece of wire with a cat chewing the far end. Didn't make much difference, did it? There we are. Now I suspect if I put a much longer antenna, especially one, you know, properly built hanging outside antenna, which I don't have access to here in my shop right now, this would work a lot better because it would be presented with a much stronger radio signal relative to the noises that are on the wire here. But just using a piece of wire in my house, this wire is really full of noise without a lot of radio signal. And that's exactly what you're hearing here. A lot of noise. Not much radio. So as I listen to that, I hear, oh, you know what, I never tuned the antenna all this time. This radio's working really quite well. Huh. Ah, it's working really well. What do I need to fix? So we come back to the same question now. Is this the performance that this radio should exhibit? Or is this really substandard, and if I just put another 20 minutes, half an hour into adjusting it, I'll get a much better result out of it? How much better can it be? When I listen to that, I hear an almost complete lack of high-pitched sounds like S's, that sound. To reproduce that sound, you've got to reproduce a pretty high frequency to get that sound out of it. If you listen, I don't think you'll hear any of that. Let's listen again. Also, just before I do that, it also sounds a little bit like it's talking through a can, like I'm doing now. I'm just something like that is what I'm hearing. Let's tune back in here. or turned it up rather. Well, you know what? I could hear a little bit of that sound in the person's voice there. Very little bit. Wow. Maybe we're done. I should follow my first rule of radio repair and don't try to fix things that aren't broken. But for sure, I must do a final alignment through here at the very least. Wow, I'm just impressed at how well this is working. So, what to do next? Tune in the signal generator and get all that set up properly. Okay, so we know the kind of volume we can get out of this radio with a regular radio signal. We should try to aim for something similar. So what I'm doing here is I'm just hooking up the signal lead from the signal generator with leaving the ground open. I'm trying to just do what I can to feed a very weak signal in here. We're going to turn this down a little bit. And now we are tuned right around 800. So we're tuned right around the signal generator frequency. So let's see if we can find it here. There it is. Well, that doesn't sound like it's overwhelming in any way. What happens if I put the ground on? That hum disappeared entirely. Wow. That's fantastic. So I have this radio plugged into an isolation transformer, which means it has no electrical relationship to Earth, to the ground, to everything that's connected electrically to the Earth, which is the entire electric grounding system. This thing has no relationship to it, but it's a radio receiver. It's designed to be affected by signals. So a really interesting question comes. Can this thing literally pick up 60 cycles like a radio station, as if it's a radio station, feed the 60 all the way through, come out the speaker? I don't think so. Well, that's just fantastic. What happens if we go back on the antenna? Hum is still there. So the hum is not inherent to the radio. Okay. And we just put on the ground. Wow. So the point I was going to make there, which I didn't make, is once I attach this ground, the isolation transformer is kind of gone from the picture in a way, and the difference in voltage between the chassis and the earth is gone now because I've connected them together with this wire. Often when you plug something in the wall, especially a 3-prong plug thing, you are in effect doing that right away. Because it would be interesting then to plug this radio right in the wall and see what happens. First, you know what I'm going to do? I'm going to turn it up to full voltage because we're still running on low. Now we hear the hum again. What if we just short the antenna right out? No change. So the hum is not coming in on the antenna. It's very low. But I will eventually get around to plugging it in the wall and seeing what happens. But for now, we're just making observations. So that sound, that sounds like two things at once. Sounds like two stations, two carriers close together, and one of them is an actual radio station. Is that the signal generator? Yep. Okay, that's right. So that's what I had going there. Where'd it go? Oh, basically this thing is now receiving with nothing more than this. Hot dog. Just keeps getting better. Oh, let me just pop down. Got quieter and quieter. Could be everything from a little bit of dirt in the volume control here. So things like that, where the radio's operating level just suddenly drop a bit for reasons unknown at this point. There, just did it again. That's the kind of thing that will cause havoc when you try to align a radio. While you're trying your best to do it, and the radio itself is jumping up and down, the signal you're using is jumping up and down, you're going to get nowhere. I think it's this. Something going on here. Don't know why I think turning that would be any different than... So this whole control is mounted on this brown plate here off the metal chassis. So this part... So I think this is connected here. And then of course they use a string that isolates this control away from there completely. Plus this is also just right on the chassis, but hadn't noticed that before. So what's happening here is we're hearing a very low level of incoming signal. Oh, I know what's happening. For crying out loud. We're still listening with this little tiny piece of wire, and I'm just a much bigger antenna. That's all that is. That's all that is. So let's give it a better antenna here. Now we're having trouble getting low enough. Good problem to have. Okay, I'm going to find a quiet spot here. Right there. Turn it up. Oh, it's not all that quiet. Right there. Where are we now? Around 6. There we go. Signal generator connected now. Wow. Good and strong. So now there's no automatic volume control, automatic level control, whatever you want to call it, in a radio like this. That comes along with heterodyne radios, but not this kind. As far as I know, not this kind. So that means it's easy to overload the front end of this radio. Which is maybe why the volume control is also right at the front end. It's a resistor shorting out the grid to the first two. That's what it amounts to. So really controlling what's reaching the first grid with this control. So what happens if you feed too much? Well, let's do that. Let's feed too much. Okay, this has got to be too much. I see the volume rises to a certain level. It doesn't get any louder after that. Can't say I really hear any distortion. Let's try it at 400 hertz. I don't hear any distortion in the signal. This is turned up full. We just whacked in there a really strong signal. Much stronger than any radio signal it's going to get, at least from this kind of antenna. Loop antenna may provide that kind of signal. Wow, doesn't seem to be any problem. You can probably figure out just how much voltage you can put into the front of this tube. Typically on an antenna, on a good day, you might get a volt on the end of your antenna feeding into a radio. Mostly, no. You're nowhere near a volt, but maybe in some circumstances. The highest level you might get is a volt off your antenna. A volt of the signal you're interested in. So I don't know what the voltage is coming out of my signal generator right now. That'd be pretty substantial. Can I just measure that with my voltmeter? I don't think so. It's under a megahertz. Why don't we try it? I've never tried this. Just using a. I don't think I've ever actually tried this. See if we can read. We'll probably get some kind of reading. We just won't know whether to believe it. Doesn't look like much, does it? Gets more signal with the lead just floating around here. Now, is that the output of the signal generator? That's an interesting question. What is that? Yeah, I don't think so. A totally false approach. I'm guessing my voltmeter won't go that high, frequency-wise. I rely on it just for 60 cycle type AC stuff. But we do have other things here we can use. We can use the scope. Use the scope. We'll try and just look at the voltage levels around here. I'll find out if I was telling the truth or not. Five volts per division. AC. So you can't quite see what I'm doing, but here, I'm just going to hook into stuff here. So on the scope should now be the signal that's being fed into this radio signal. Pretty low. Let's turn this down here. Turn this up a bit. Not so low. Frequency hum in there or something. So just quiet this down a little bit more. Okay, here we go. Strange stuff. This is what's coming right out of my signal generator. Why it look like that? Okay, back up a notch. Leaving the radio out of the picture for a minute. Why am I getting an image like this on the scope? Wow, okay. What's happened here? Let me take this little box out of the circuit. Hey, you never know. You never know where the lessons are going to come. So the hummy thing has disappeared. Still doesn't look right though. You would think it would be perfectly symmetrical. It doesn't look symmetrical to me. Hang on one moment. Gotten a shock from this camera, from that little metal grill. That's the microphone. I don't use this as a microphone, but that's the microphone grill. But I had been holding this camera and touched something in my shop and gone through the roof. So I got to be very careful. Occasionally you'll see I have tape around this when I'm feeling more inclined to protect myself. I'm trying to give you a better shot of the what's on the screen there. Oops. So I did plan to just play around in here this morning. Did I say that? Oops. Hang out. Now, what I'm seeing here is the upper part of this wave looks bigger than the lower part. So it doesn't look to me to be perfectly symmetrical about the center line. It says something about my signal generator, I'm afraid. Let me change frequencies here. Is it just my imagination? On DC. Doesn't make any difference. Now it's very distinct there. Definitely the top looks different than the bottom. For some reason I can't get it to trigger. I'm having trouble triggering because the signal is full of RF like this, and then too much for the circuit to figure out. There's kind of sort of triggered there. Well, I can't worry about that right now, but it's not an effect of the radio. Signals like this coming out of the signal generator, at least when displayed on the scope. I'm going to try the other scope input just to be sure here. That's exactly the same. Okay, next little experiment here. Feed that signal, as weird as it looks. Let me turn it down a little bit. Back into the radio. And I had mentioned that sometimes you can't see both of my hands and what I'm doing because I'm blocking the view. So, and you heard the level go up and down. That was me turning the volume here. So I try to make sure that I get on camera the things that are happening so you can understand what's going on. But sometimes I don't succeed. I'm not watching the image very much, I must admit. Okay, so there we've got the signal coming in. You can hear it coming out of the speaker. Sounds fine. Radio's tuned well. So we'll now take a look using the scope at all these different grids. And I mentioned before that doing this will disturb the radio. Let's see if it really does. So we'll start with the first grid here. I don't see anything happening. Okay, I'll make this a little more sensitive here. No signal at all. Would expect to find something similar to what you just saw here. Okay, let's go to the next grid. So this is what I was saying about if you attempt to put any instruments on this radio, you'll knock it out because it's all so high impedance everywhere. Why nothing here? Something there and we can't see it. Okay, so the scope is, this doesn't even make any difference. The radio is actually starting to show a lot of sensitivity here. Now I've got the signal generator set down around where I have it when I'm working with most radios that are working well. So I'm starting to imitate a weaker signal coming in on the antenna. In fact, this is normally here. This will be the real test. When I get down to this level, if the radio can still pick it up. Oh my gosh. Huh. What is there to fix on this radio? I mean, I'm now feeding a very, very low signal. The actual voltage of the signal, if I calibrate this, even without it calibrated, we can kind of get an idea here. Okay. Times 1. Okay, this is the meter showing the modulation right now. Did I say the meter? The meter. This I have this connected to an incorrect output impedance, so the meter may not be accurate. We don't need it accurate. I just want it within a factor of 10 anyway. So I've calibrated the meter now. It's calibrated the unit. So it's currently putting out times 1, 10 microvolts. That's my impression of what's going on here. 10 microvolts. That's turned up full. I can hear a 10 microvolt signal. That's really very, very sensitive. No wonder they don't have 5 radios or 6 of these stages. 3 of them is plenty. Now the question is, can I, starting with this, tune this guy up? Follow the proper procedures to do it. I have a tube, special tube I use, this guy here. Follow the proper procedure and see if we end up with something better than we have now. So what I would need to do is somehow come up with a quantitative value for what we have now. I could do it by using speaker voltage. Use it just by using my ears. I mean, I can hear how loud that is. It's a good chance I'll put this test tube in here, and I will need a different input level to drive the radio during the test. It can't pass this low level of signal. Thought there. Okay, so to start off with here, I've hooked up my voltmeter to the speaker terminals at the radio. So I believe there's a pretty strong DC voltage there. I think I can just do this. I can find out. Nothing. Okay, nothing. I'd have to look at the circuit diagram to figure that out, but I'm not going to bother with that right now. So this is a voltage going to the speaker right now, 0.9 volts AC. If I jack up the, if I change the volume on the radio, can hear it better than I can see it in the meter. To prove the meter is really reflecting the sound coming out of the speaker, because it still shows 0.8, almost 0.9 volts. Just crank this up. Could be some more signals of some sort mixed in with the audio we're listening to, and signals that can't be reproduced by the speaker. Maybe that's what's generating that voltage there, or here rather. Maybe there's a hum in there that I can't hear it out of that speaker. I don't know. But this volume level, which I can hear fairly distinctly, really doesn't do much on the meter. So we'd have to do this at a higher output level. Okay, so this isn't particularly calibrated anyway. We'll just turn this up. Let me turn it up so the meter reads 1. As soon as I get in to turn it up, it's up. I'm just touching a plastic knob here. Jeez. So much sensitivity. Man, how am I going to do this? Okay, from over here now. Tuning it. Well, that works pretty good. My ears are pretty good. Bear in mind, it's not properly aligned through here, so yes. Yes, sir. What's going on with you guys? I can't let you go out. It's all snow. There's nowhere for you to go. I know. I would like it to be spring, but see how he's turning his head? He's indicating to me he wants to go there, out there somewhere. He's talking to me about it. They do it all with body language, cats. That way? You want me to go that way? Now he's getting distracted. And now he's fully distracted. Okay, enough of them. A little break from the tension here in the shop is good, though. So I'm tuning the radio to try to get absolute maximum on there. Even this is a bit of a challenging exercise here. So 155. Let's see if we can get any higher. Okay, 157. I'm just barely touching anything here. Looks like 155 would be about the best we can really count on getting. Where'd it go? Where'd it go? Oh, there he is. Okay, now, against all the rules of radio repair, I just can't hesitate. We've got 3 controls here that affect something called balance. And we got 3 controls that affect the actual alignment of the tuning through here. I want to adjust the tuning. Try to maximize that thing. Yes, I'm using a metal tool. Watch it now. Holy crap. Wow. Let me turn it down. Turn it up a bit. Oh, peanut. Okay, starting there. And now go to the next tuning. So I think I'm tuning against this. I think. This one's the tuning. Yeah, you're not supposed to do this kind of thing. Let's tune them all. What the heck? Going down. This stage doesn't seem to do much. Did that. This, I believe, is the feedback. Oh, smokes, what happened there? What's happening there? Something shorting or... oscillation. Let's just put it there. Yeah, a little more out of it. Let's keep fiddling. Oh my gosh. Oh, oscillation. Go back. Ah, this metal thing is having an effect now. It wasn't up until there. Have anything plastic that'll do this. Uh-oh. Almost 4 volts on there. Let's turn it down again. Keep going. Oh, that didn't sound good. Peaked. Just watching that meter. What I discovered earlier on by fiddling with these is that these things, they affect each other. So there's no way you're going to go once through this and get anywhere, I think. Look at that. That tool's really throwing that one off. Maybe as the radio gets more sensitive, the tool is becoming more nut drivers. Now let's keep going. Seems the tighter I make this, the better it works. Right down the line now. I don't know. See, this one's cranked wide open while I have the tool on it. It just sounds like a short going in and out. This guy wanted, oh, oscillation. Something not quite right. This one here. Oh, meter, don't do that. Now I've lost track of the overall signal level. What's that tell you? Where'd this cat head come from? Sneaking up on me here. Ah, you threw me right off. I saw a 2 there for a moment. Wow. Holy, I got this thing super sensitive now. Where's that noise coming from? Hate to do it. Tune it a bit. No, it's just from the radio. Okay, I don't know what's happened here. Let's put on the antenna. See what we get. Maybe I've been fooling myself here. Okay, once again, just on the junk wire antenna. Unfortunately, the station is coming right at a point where there's noise interference. So you gotta hear both at the same time. Oh, it had a very nice tune-through sound to it. So did that. Be nicer if you pick something up here. It's very quiet now up at this end. Oh, you know what I'm not doing? Back. I'm not tuning this. 2 hands on the tuners. Try it again. This tuning is all the way one way. I wonder if this is related to this. No, I don't think so. So it sounds to me now like I've got it tuned pretty sharp. The response curve is pretty tight. That's what it sounds like. So what I'm wondering is that kind of sound just being generated by the radio itself? Or is that really there? The other thing I'm wondering is, wow, can I get anything more out of this radio? I mean, what more can we possibly get out of it? It's working off a lousy antenna. It's showing a sensitivity similar to modern radios. I don't see how I can improve this much. Even if I go through the proper... I'll have to go through the proper alignment procedure. I have to. Okay, but that's enough fiddling around now to find out that the radio is really very sensitive. It's really working quite well. Is it working the way it's supposed to? I still don't know that. So I think what I will try is I'll follow the formal alignment process and see if we can beat this operating situation. I'll have to record the settings on everything here, and we'll see. You again. Come here. He won't let me get near him. As soon as I make a move, he's running. Okay, so I think that's it for today. It may seem like we didn't get anywhere, but I certainly think it's great. Thanks a lot. See you next video.